Yeah, single slit pattern, but it's going to be, the intensity is going to be 50% lower than over here. Here it's this one and this one. It's going to be the same exact pattern. The only difference is because what happened? What did you do over here? You made this slit made a pattern, and this slit made a pattern. But it was the same exact pattern. Right? So if you shut down one of the slits, you're still going to have the same exact pattern, but you're going to shut down the intensity by 50%. So that's all you do here. You just you changed it into this. This is what you did. So by blocking off this slit, now there's only one slit. So now you change. Now this is your scenario. And so what are you going to make? Are you going to make a double pattern, or are you going to make a single slit? Since you, the person that Looking Glass universe, since you did this, you shut down one of the slits, and that's why it turned into a single slit experiment, because you shut down one of the slits. What did you expect? But she thinks it's leprechauns in her. Now, if you put this filter in and it was vertically oriented, now it's letting in this slit and it's not letting in this slit. So basically, you turned this, if this was vertical, you turned it into this. You turned it into a single slit where this was open. And you get the same pattern because you're getting the same, because you're doing the same thing. You're letting light through the single slit, man. So it's basically doing the same thing, man. But before we go on to Looking Glass universe, okay, you can understand, if you put two filters in, you're going to make a single diffraction pattern, because you shut down half of the places where you can interfere, and if you do this, add this in, all you're doing is changing the intensity, because each one of these makes this same pattern. This one makes this pattern, this one makes this pattern, and when you put this in here, you just take one of the patterns away. So what? All that does is change the intensity. It doesn't change the pattern. Now you heard the classical explanation. Now let's go to the Leprechaun, or the quantum explanation, explained by Looking Glass Universe in a video on YouTube called I Did the Quantum Eraser Experiment at Home. And she's oblivious. She has no clue. She has no idea what the FRESNEL Arago laws are. None. What did she learn in college?
In quantum mechanics, things behave differently the moment they know you're watching. I'm going to do an experiment where light changes from this to this, all because it was being observed. But why do quantum objects care if they're being watched?
They don't care if they're being watched. They care if you punch them in the face, okay? There's a difference.
This is the mystery that got me obsessed with quantum mechanics years ago. This is a double slit, which hopefully you can see. And now I'm going to put the double slit in front of the laser and turn off the lights. And this is what the pattern looks like. And so now you get this double slit interference pattern, which looks like a whole bunch of little dots, right? Like there are these sort of bigger regions, and then in each of those regions, there's like little sub-regions as well. That's the double slit pattern. Measurements cause collapse of the quantum state. So here's what that means. Light like this can be in a quantum superposition of doing multiple things at the same time. So for example, this light is in a superposition of going through the left slit and the right slit. And you can see why that's totally fine. It'll just lead to this overlap. But this rule says that this is fine as long as we don't ever try and find out whether the light went through the left or the right, because when we do, we cause it to collapse. So for example, if I was somehow to measure what the quantum state was doing by, let's say, looking at the light and seeing it going through the left slit, then I would collapse the state. And so it would have to only do one of these things. And let's say the right one might disappear. And so the rule says, when you look to see whether the light went left or right, then you collapse it to just going through one of the slits.
This is Chris the Brain.
When scientists say we are observing which slit a photon goes through, they are lying. We observe jack shit. So we're not watching a photon pass through a slit. We can't. It's impossible. The word observe makes it sound like we're watching as the photon passes through a slit, but we can't. It is impossible to detect them without changing them or making new ones. In other words, the problem with using the word observe when talking about photons is that you can't observe them without messing with them. In fact, you can't observe anything in the quantum world at all without interfering with it. And most of the time, we are observing quantum objects. It is done by shooting them with a laser. That would be like observing the position of runners in a marathon by pelting them with rubber bullets and measuring the angle they bounce off. Gee, I wonder why measuring them makes them change position and velocity. Must be that observation changes reality. Of course you change reality when you shoot shit at it. That's how reality works, you pretentious morons.
But there has to be a cleverer way of figuring out whether the light went left or right and collapsing the state. And in fact, there is. Here's how we're going to do it. What if we used this stuff to filter out the light? So let's say that we have some light coming in some random direction here, but we only let through light that is oriented up and down, like this. So only this light would be able to go through. Or what if we turn the filter around and now it only would allow light going this way, so this light would go through, but nothing else? Well, we could do that and it wouldn't really do much for us. But here's the really clever bit. Why don't we do both? Why don't we put a filter in this direction over just the left slit and a filter in this direction just over the right slit? That means that light that makes it through the left slit has to be oriented like this, vertically, and light that makes it through the right slit has to be oriented like this, which is horizontal. What we've just done is we've marked these two slits. The light coming out of them are very different, and so if we want to know whether a bit of light is coming from the left slit or from the right slit, all we have to do is put a filter like this, because a filter like this will only allow through vertical light, and it won't allow through this horizontal light. And so by measuring this polarization, we've also measured which direction the light went through, and we've collapsed it to only going through one, which is the left slit. If our rule that measuring the quantum state really causes it to collapse is true, then we should see that the light goes from being a double slit pattern to a single slit pattern. So if we can put these filters behind the two slits, then we'll have a way to test whether measurement collapse really happens. It was very, very finicky, but I finally got it to work. Here are the little filters that go behind the slits. So let's see if this really causes measurement collapse. This is the new pattern, and you can see that it actually looks quite different. Like, the big patches are still basically where they were, but now there isn't these little lines in them. And just to see how different this actually looks, let's turn the camera around. You can see that there's basically only one beam that's really visible, which is the middle beam. The tiny little beams that you see in the double slit pattern are mostly gone. So observing this light really did change it. Just to double check that we really have collapsed this light into just going through one slit, I compared this pattern to what would happen if you did just have one slit to start off with. And you can see that they look very, very similar. The spacing of these bright bands is pretty much identical, which proves our hypothesis that observing the light really collapses it.
Do you see that she literally, to our faces, she said that she put a horizontal filter on this bottom part, only lets horizontal in, and then she blocked that with a vertical filter, which would block 100% of it. So she tells us to our face she blocked 100% of the light that came out of this bottom slit. She told us to our face, okay? And then that only leaves one slit left for the light to come out of. And then she says, I don't understand why I'm getting a single slit. This proves that leprechauns exist, because I'm getting a single slit pattern. And I didn't do anything to it. I did nothing to this. Well, she's telling us at the same time that she literally blocked this bottom one off by putting a horizontal filter and then a vertical filter on it. She blocked it off, and that only leaves one slit. And then she tells us to our faces, that leprechauns exist, and she's collapsing the wave function with her mind. Her mind has powers of if she observes something, she can change reality just from her observations. It had nothing to do. It had nothing. Don't look behind the curtain. Had nothing to do with her blocking this off with a vertical and a horizontal filter. No. It had nothing. That isn't why it went down to a single pattern, slit pattern. No, it's because of her magical powers.
That would be like observing the position of runners in a marathon by pelting them with rubber bullets and measuring the angle they bounce off. Gee, I wonder why measuring them makes them change position and velocity. Must be that observation changes reality. Of course you change reality when you shoot shit at it. That's how reality works, you pretentious morons.
These people at the bottom, yeah, they come through, just like over here, they come through, the verticals. But now the horizontals they don't make it to the wall, they get filtered out. So you've, in essence, just changed it into, literally, you've changed it. You might as well have just went up and put your finger on one of the holes here, right on one of the slits. That's what she did. And then she acts like she's surprised. Gee, I put my finger up and covered up one of the slits, but I'm going to call that I collapsed the wave function. I'm going to call that leprechauns came over and they messed with it, because now I get a single slit experiment. I don't understand. All I did was cover up one of the slits with my finger, and then leprechauns came out and they messed with things. Now I have a single slit instead of a double slit pattern on the wall. This all makes sense.
But here's the really trippy bit. So this filter here is what allowed us to know that the light is going through the left slit. But what about if I just remove it? Here's what the light looks like with the filter, and here's what it looks like without. It's basically the same. It just looks a bit brighter without. So what on earth is going on?
When she has it like this, the horizontals on the bottom can only interfere with this slit. They can't interfere with this slit because they do, but they get blocked off with this filter, right? So you create a single slit pattern, right? And then this one does the same thing. It can only interfere with this slit. It can't interfere with this one because you blocked all the verticals coming out, right? So it makes a single slit pattern. But they're the same exact pattern. They superimpose right on top of each other. You can't tell them a difference. Then when you put this third filter in, all you're doing is taking out one of these single slit patterns, because you had two single slit patterns right here that were superimposed on each other. All this one does is shut down one of the, on this one, it shuts down the bottom whole slit, and so it turns it into a single slit. You know, you just take one of the patterns away that you already had that were both superimposed on each other. So now you have to, now if you take this away, right, now it gets twice as bright because you got the single slit pattern from here and a single slit pattern from here, right? So this gets twice as big. The only way you can get the double slit pattern back is by letting these two slits interfere with each other. That's where all the fine lines come from this, from the verticals coming out of here and interfering with the verticals coming out of here. But you've stopped that with this horizontal filter. The same way up here. The horizontals would come out and interfere with these horizontals coming up here, but you took that out of the equation with a vertical filter. So the fine lines can't come up. You have two options. You